Let's look at some more of the homework questions from last week. Problem 4 asks us to calculate the limit as x tends to 1. The function we are looking at is x squared minus 2x plus 1 divided by x squared minus 1. Whenever I look at a limit, the first thing that I like to do is to attempt to evaluate at that limit point. So here I have a rational function. This will be continuous so long as the denominator is not equal to 0. So in the numerator, I have 1 squared minus 2 times 1 plus 1. So 1 minus 2 plus 1, that'll be 0. In the denominator, I have 1 squared minus 1, which is also 0. Now this is one of our indeterminate forms, so evaluating at x equals 1 is not enough. We got to do a little bit more work. Since both of these are polynomials, I now know that x equals 1 is a root of both the numerator and the denominator. So I should be able to factor out that root. Let me copy my problem down here. On the numerator, I want to factor this polynomial. I already know that x minus 1 is one of those roots. The other root here needs to be the number which multiplied by minus 1 gives positive 1. So I am forced to say that this factorization must be x minus 1 times x minus 1. And I can multiply that out and double check. This is what I get. On the denominator, again, I know that x minus 1 is one of those roots. Whatever the other root is, it should be the number which multiplied by minus 1 gives me minus 1. Well, what number can multiply onto anything and not change the value? I have no other choice but positive 1. You can also think of this as the difference of squares factorization. So anytime you see x squared minus a number, the roots are plus the square root of this number and minus the square root of this number. Cool. Now that I've written it out, I see both of the factors of both of these terms have factors of x minus 1. And since I'm working in a limit, I can actually cancel these. And now the limit of this new function is going to be the same limit as the limit of the old function. So this is a trick for working with rational functions. And now I'm going to try my evaluation idea again. I'm going to try to put in x equals 1. And as long as I get a sensible answer, because rational functions are continuous except at where they are undefined, I would be allowed to use that result as the value for my limit. X equals 1 on the numerator gives me 0 again. X equals 1 on the denominator gives me 2. And 0 divided by 2 is a number, that is 0. So from this point, I can say that the solution to this limit problem is 0. Let's look at this another way. So again, I have the limit of x squared minus 2x plus 1 divided by x squared minus 1. X is approaching positive 1. We previously saw that this is the situation where evaluation at x equals 1 gives us 0 divided by 0. This is one of our undetermined forms. In the case where we have 0 divided by 0, we can use L'Hopital's rule. So remember that a bit. We have two functions. We have a numerator and a denominator. Both of these are nice functions that have derivatives, right? They're just polynomials. And both of them are tending to 0 at the same time. L'Hopital's rule there it is, good old French name. This rule tells us that we can replace the numerator of this function by the derivative of the numerator. We can replace the denominator by the derivative of the denominator. And now this new limit will give us the same answer as the old limit. So if I'm only looking at this numerator, my derivative here is going to be 2 times x minus 2 plus 0. Just a nice polynomial derivative. My denominator, only looking at this part, my derivative is going to be 2 times x minus 0. Okay. Now, it looks like I might have a cancellation here. Let me rewrite this and factor out the 2 on the numerator and the 2 on the denominator. And these 2's will cancel, since 2 divided by 2 equals 1. I dropped the zeros along the way because stuff plus or minus 0 is still the same. I'm going to try evaluating this limit, again, because I just have a rational function. As long as I get a sensible value here, it'll be nice and continuous, and the number that I get will be the value of that limit. In the numerator, I get x minus 1, which will be 0. In the denominator, I get 1. Now this is a different fraction than I got on the previous page, but 0 divided by 1 is still 0. So there are 2 of the ways we can solve this problem.